All right, hi everybody. So today we're going to look at a example question. Okay, so a rifle is aimed horizontally through its bore at the center of a large target 200 meters away. The initial velocity of the bullet is 500 meters per second. So we want to find these two things. Where does the bullet strike the target? And to hit the center of the target, the barrel must be at an angle above the line of sight. What is that angle? So basically we have this. Okay, here's my rifle, here's a bullet, it shoots, okay, and due to the fact that it's so far away, okay, due to the fact it's so far away, 200 meters, there's going to be some drop. So what it's saying for this first part, where does the bullet strike the target? We're basically going to say, okay, what is that drop due to gravity? So what's my delta y? Well, this first part of the question is actually a horizontal projectile situation because it even states at the very top right here, it is shot horizontally. Okay, so I'll say A because it's the first part, even though it's not labeled A. Well, let's actually start by listing out all of our givens for a horizontal projectile situation. So, acceleration in the y-axis is always negative 9.8. Horizontally, initial velocity y is 0. Acceleration in the x is always 0. And our velocity is constant at 500. I'm going to add in the delta x is 200 meters. We want to find delta y. This is one of those few and very far between situations where we can start with the x-axis because we need to solve for time. We need to figure out the time in order to do this because kinetic equation-wise, I don't know what the final velocity in the y is, so I don't want to figure it out and just deal with it. Okay, so delta x equals v initial xt. All right, so 200 is equal to 500t. Time is equal to 200 divided by 500, 0.4 seconds. All right. So for y-axis, now to find delta y, we'll use the second one. So delta y equals the initial yt 1/2 at squared. That goes to 0. So delta y is equal to 1/2 negative 9.8 times 0.4 squared. So solve this out, and you should get a delta y is equal to negative 0.784 meters. So this bullet shot, travels 200 meters, and it drops almost a meter. Okay, it drops over 78 centimeters. That's a good drop. Okay, so now for the second part, it's saying, okay, is if I was to take this rifle and I was to launch it at some angle theta, what would that be? Okay. Now, it's still going to travel 200 meters. We just now want that when it goes through its little progression, it's going to come and it's going to hit and it's going to strike the target. Okay. Well, actually, if we kind of think about this, this is another situation where we can use the range equation, okay? Because we want to orient this thing, okay, where we want to launch it and have it hit the direct center, okay? And we're going to have kind of stuff stay level. So I have 200 is equal to 500 squared sine of 2 theta all over 9.8. Okay, so I'll go through this math a little slower. I'm basically going to start by multiplying the 9.8 over and squaring the 500. So we get 1960 is equal to 2540. 1, 2, 3, 4. Sine 2 theta. Okay, divide both sides by the 2500 or 2500,000. Okay, this is all multiplied together, so you can divide both sides by 2. And then when I get theta by itself, sorry about that, I had to quickly step out, talk to a teacher, and we get theta of 0.22 degrees. Which might not seem like a lot of angle, okay, which really isn't. It's less than a degree, but you're going at really fast speeds, so it should all work out. All right, have a good one, kids.